He previously was assistant professor at the Princeton University School of Architecture and at the Delft University of Technology, and a postdoctoral associate at the Department of Architecture at MIT. He holds a PhD in Design and Computation and a Master's of Science in Architectural Studies from the Department of Architecture at MIT. He came to MIT as a German American Fulbright scholar, a scholarship grantee, after completing a professional degree in architecture at the University of the Arts in Berlin. His work in architectural robotics has been exhibited at the Istanbul Design Biennial and the Seoul Biennial of Architecture and Urbanism. His current research and teaching focuses on embodied computation, exploring the extensions of architecture's material form into the behavioral through physical, actuated, and sensing prototypes of space. Today, we will have a 20-minute presentation from Axel, followed by 25 minutes conversation with Stefana Parasco and Q&A as time permits. I'm going to say also a few words about Stefana, whom you already probably know from the event. Dr. Stefana Parasco is an architect with a focus on computational design and robotic fabrication. And prior to joining Princeton University, she completed her doctorate at the ETH Zurich and her architectural studies at the University of Stuttgart. After her studies, Stefana focused on research in digital design and fabrication at the Institute of Building Structures and Structural Design at the University of Stuttgart and at Gramazio and Kohler Research at the ETH. In Stuttgart, she co-led the ITKE Research Pavilion in 2013-14. It's been a long conference. Sorry. Developing and implementing strategies for the design and robotic fabrication of structures built of fiber-based modules. Stefano is also on the board of directors of ACADIA and is co-chair of the conference this year. So I'm going to virtually bestow this award upon Axel, who will be receiving the physical award very soon in his mail. I'm also going to ask for a virtual applause in recognition to this award to him, whatever that looks like, an emoji, some words on the chat, whatever you feel called to. And I am going to play the pre-recorded presentation that Axel has shared with us, and it will be followed by Stefana's response and questions. So I'm going to go ahead and do that.
Expansion of computation. Hello, my name is Axel Kilian. First of all, I'd like to thank ACADIA for the Excellence in Teaching Award. I'm very honored to receive this award, and I'd like to take my time here to reflect on both teaching in the context of my research and work in embodied computation. We as humans embody computation in our brains and in our bodies. In mechanical engineering, similar dynamics can be observed in this transition from mechanical complexity to algorithmic complexity and ultimately closed box complexity. Machine learning has shown an example of the transition of a helicopter control head towards vector thrust control in drones, which use algorithmic feedback and sensing control to replace the analog computation of the helicopter precedence, and ultimately the distributed learning through body form in the example of the robot farm at robotics at Google, where machine learning guided learning is at the center of increasing knowledge about the handling of unknown objects. What if some of those dynamics are preloaded in a computational sketch from 2003, really changed my perception of design towards one of an approach of discovery through the definition of constraints rather than the resolution of formal intents through post-processing. Here, an approach had been custom programmed using processing, using a particle spring implementation by Simon Greenwald to explore how the definition of design intent through topological connections and geometric length could result in an emergent discovered geometric outcome in equilibrium, which led to a rethinking from me of what design process and also design tools role in computation can be, and has also since then become completely mainstream through the introduction of great implementations such as Kangaroo and Grasshopper and other processes, making this initially more complex process easily accessible. At the heart of this is the intent to expand the design form finding towards one of steering of design, where in this program sketch and games engine, force limited moment actuation is placed at the nodes between parts, which allows a hybrid result of a partial catenary and partial moment resisting beam structure, extending the formal vocabulary of form finding towards one of steering of form, deliberately taking on compromise for the overall design intent. And if one does not stop with simulation, but actually extends this into the build environment, in this curved crease actuation example, together with Sigurd Jansen at Princeton University, one can affect the structural behavior actively, in this case, the introduction of forces through pneumatic actuation. And also, this behavior is literally a response of the organization of material distribution, in this case, the 3D printed artifact, which could be further extended by embedding pneumatic actuators or other forms of actuation in the material construct. What if we don't stop at the static distribution of matter? Was the question of this quick research study with Ryan Jones, where we explored putting a container of viscous liquid at the end of a robotic arm and agitating it rhythmically to discover that an initially chaotic looking fluid actually contained a reappearing constant liquid form when strobing the camera frames. This set us up on looking for ways to sort of capture this fluidic instance, and also rethinking the definition of form, not through a purely geometric descriptive approach of surface, but through a series of actions. So initial tests were done in baths of liquid hand soap on the left, further extended to a series of hydrogel as the carrier surface. And here the injection of the liquid allows for a mixture of geometric intent through the path of the nozzle and ultimately the expansion of the liquids inside the carrier surface, resulting in a final plastic geometry, which is a combination of the two, where partially final form is defined by the fluid dynamics and partially by the precision of the insertion geometry, but ultimately resulting into a faster and also more open-ended material definition than traditional three-dimensional deposition approaches. This created an interest in how we could extend also those types of robotically controlled behaviors into the architectural realm with an installation at the opening of the Stephen Hall design. Draw attention to the particular organization of the building at the entry level with skylights submerged in this pool connecting to the underground lobby of the building, and using the actual robotic device of the pendulum to provide, in a sense, a heartbeat of this underneath happening musical performance, and also stitching together the spatial organization of the building, and ultimately using the caustic properties of the water surface itself. And all of this comes together ultimately in this robotic pendulum, swinging above the liquid pool and shining into the water, which in turn is actuated through a pneumatically driven piston. You can see here where the orchestra is placed on a reflective stage, which brings back the pendulum reflection clearly visible to the surrounding audience, and also captures the rhythmic expansion and contraction of the fluidic lens of the water tube. But this, the formative dimension of robotics and embodied computation was becoming a central part of my work much earlier already, when in the robotic concept car project, Smart Cities Group, I became increasingly frustrated with the limitation of the exploration through form, and stumbled across like the potential of behavior in defining a design expression for vehicles. In this sketch, we can see how the sort of perception of the vehicle is changing through the behavioral actuation of its degrees of freedom, which allows like for different expressions with the same static formal expression, which led to a series of prototypes, ultimately also selective prototype on the right, where the selective prototype is the first instance for me, together with Peter Schmidt, Patrick Künstler, under the Smart Cities Group, Bill Mitchell, to think about how to implement partially yet conceptually complete prototype to experience one-to-one physically a subset of features of computational constructs, in this case, the robotic car, which became a central theme in both my research and teaching as we're going forward. And a follow-up project that brought back the architectural scale was the actuated tower of who, what, when, where, like together with Philip Block, John Snavely, and Peter Schmidt. To the foreground, the crucial need for computational control strategy, where previously in the car, it was a 6 degrees of freedom construct. Here, the tower already has 8 degrees of freedom, which made it practically impossible with 2 thumbs to control through joysticks the structure in a meaningful way.
All right, I believe we had some kind of technical glitch with the sharing video, so I'm just going to play where the video stopped when we stopped going live. We're going back.
who, what, when, where, like together with Philip Bloch, John Snavely, and Peter Smith. To the foreground, the crucial need for computational control strategy, where previously in the car, it was a 6 degrees of freedom construct. Here, the tower already has 8 degrees of freedom, which made it practically impossible with 2 thumbs to control through joysticks the structure in a meaningful way, which led ultimately to a follow-up research project called the Bow Tower, which was leveraging some of the early prototypes of an active band version of the tower and brought it back, and where I combined it now with, from the beginning, computational control and feedback, sensing and feedback control strategy. Now the sort of extension of form through the behavioral in a more coordinated and real-time control strategy, as shown on the left, and also the ability through sensing body state with an angle sensor accelerometer on the top, some beginning of simple sort of body-body interactions of the tower responding to the deformation by myself with a reactuation to stand back up straight. So here, the form of the tower gets quite radically extended through the behavioral, and the addition of sensing allows for an open-ended set of structural responses to human interaction. And it also led to insight that simulations really could also come in the way of a robust response. And instead here, a simulation-free control strategy was adapted, where the tower literally becomes a physical function that is being searched with the sensor on the top being the return value. So in this case, a very primitive yet effective strategy of a simplex search was used together with François Savarin to feed 6 values to the physical structure, let the structure solve this physical equation by taking on an angle and using that as to be optimized function value. But these types of research explorations all still put the robotic entity as an object at the center of an outward-facing universe, just as our own sensatory map is by the majority showing like an outward-facing sensory set of organs like skin and face and fingers and legs, and only a fraction of it going towards the internal intestines. Our machines are a mirror of our evolutionary selves in that sense, like a sensor map of an autonomous car shows on the left, where a large range of sensors is outward facing, but only a fraction of sensors are inward facing in the occupiable space of this machine, which makes sense from an evolutionary standpoint, where an intelligent being swallowing another intelligent being usually meant someone is being eaten, and there's little incentive for establishing a form of interaction between what is here the Jonah and the whale with the entity on the outside. But as we move into the architectural context, this becomes a fundamental question of what is the form of language that we can establish, whereas nature gives few precedents, where most of the intelligent, more interior kind of environments are more ecosystems. So the flexing room became that selected prototype for me in reflecting on the embodied computation as a machine that is inhabited by other intelligent beings, and the question of how an exchange can be established. So when architecture becomes robotic, its autonomy means that the design process must extend beyond schematics, design development, and construction, and go into the lifespan of the building, thereby becoming a learning process in the context of its environment. Design is therefore not to be understood as an isolated process at the beginning of a sequence that entails fabrication and habitation, but rather to be treated as one continuous process, linking the design process with the process of use. The term embodied computation stands here for the expansion of computation beyond that of an abstract, predominantly computational process into a hybrid physical computational one. Computation extends beyond the limitations of describing the object, and it reaches into the realm of lived-in architecture, thus enabling autonomous architectural robotics. These principles were also at the core of a series of architectural robotics studios I taught at Princeton University, together with TAs Jeffrey Anderson and Ji Shi and Tae-Sung Woo, which leveraged the concept, which I mentioned earlier, of the selected prototype as a vehicle for constructing multi-scalar, experienceable prototypes of an architectural robotic kind of approach to design, such as here shown in Ji Shi's case from 2015, where he explored a social network of rooms that could connect through the finite state automata and play matchmaker for its inhabitants, who would be faced with a constantly variable set of floor plans and unpredictable social encounters through the agency of the architectural entity. Or here by Mark Alciari, who built literally a changing room, which used as its body language actuation of its footprint and variation of the light zones in its room fingers to play with and alter the color perception of its inhabitants and the sense of self through the color of their clothing and their surroundings. And again, selective prototype of choosing a full-scale subsample of an architectural idea that becomes testable and explorable, and serves as the sort of basis for reflecting on the larger intent. Or here, Tyler Wojcik's provocation of re-seeing architectural components as independent entities that can take the liberty of engaging or disengaging from their role in the tectonic context, such as this pair of walkable columns that, together with their column brethren, can dynamically organize and coordinate the task of lifting and holding the roof, and thereby ultimately fulfilling sort of long-held anthropomorphic image of the column figure, but also provoking a rethinking of architecture as a loosely organized sort of society of parts. And last but not least, François Sullivan's project of these volumetric space modulators that allowed for the curating of an exhibition crowd through selective expression of space by expanding, blocking and opening circular trajectories and redirecting both sights and sounds and the flow of people in this ever evolving exhibition space that had a basic sensory awareness of its surroundings. And also in parallel, on a more research oriented trajectory with back then PhD student Tae-Sung Woo at Princeton University in the Embodied Computation Lab, which we started together with Forrest Meggers and the various deans at Princeton University, and exploring full-scale collaborative construction of robotics, in this case by assigning to the robotic arms the changing, missing equilibrium forces of an in-process construction of compression-only arc structures, where each missing equilibrium forces of an in-process construction of compression-only arc structures, where each robotic arm would complete the force diagram at the stage, allowing for a scaffold-free construction. So in terms of teaching, this is a good cross-section through what are the fundamentals, motivators from my approach to teaching, which is at first identify a core motivation in the project, which is then to support the student collaboratively in developing the necessary fundamentals in technology and technique to support the exploration of this core motivation. So to establish fluency as a crucial aspect for the next step of criticality, because I believe only if one is able to speak the language of the domain one critiques, can one discover some of the more fundamental embedded challenges within it. So this bears the danger of becoming too conformist and also becoming an expert in the domain and by losing distance. But I think it's finding this balance between fluency and the ability to speak the language to then express a critical stance that is at the core of my motivation to teach computation. And ultimately, through this criticality and also the individual identification of a core motivation for the work, to enable an increased diversity of cultures within the discipline, as I think it's absolutely essential to enable and empower and also provide, encourage the creation of platforms for different voices to expand our notion of what computation can be, is, and will become. Thank you very much again for the award, and I look forward to follow-up discussion after this talk.
Thank you, Axel. Thank you so much for this fantastic talk. And many, many congrats also from my side. We are really extremely thrilled to be able to give you this award. And I think especially in the context that we live right now, combining design architecture with technical knowledge is really something very challenging. And I think you've set a precedent on how to embed this type of knowledge into the teaching of architecture schools. This is extremely valuable for all of us. So many congrats one more time. I do want to start off directly by talking a little bit more about teaching and towards some of the points that you make towards the end of your video, where you speak about technical literacy in architecture students and how the knowledge and the skill build up is super important, but at the same time, it bears a risk of becoming too much of an expert, losing the distance, etc. I think that thought is very, very interesting. And I think that's something that many schools struggle with, and students and researchers, you find yourself either in a position where you're really fascinated by the technical details and you just get sucked into all the exciting research that could be done that way, but you lose connection with architecture and design and what we're actually here to do. Or you might find yourself on the other side where it's like, I want to think about these concepts, but I don't want to be the person that does this technical stuff myself. There should be others doing it for me. So I'd just like to hear more about how you think we can avoid this separation, how you think we can engage students from this perspective, and how we can bring their really focused technical knowledge together with the architectural education and not in a separate, super specialized program environment.
Yeah, and thanks, Stefana, for the response and intro also, and for having me. And again, thank you in person for the award to ACADIA and everyone I've ever collaborated with, and also for having had the chances throughout the years to work and be part of great institutions, and having also amazing students, which is, of course, a key component of being effective or having any impact as a teacher. So I think the question of how to approach teaching in this sort of dilemma, I think, as I said, it's crucial, I think, to be able to explore and experiment in a domain, having the actual bottom-up knowledge to stumble across things that one may not be able or familiar to express, right? Without speaking or without programming in this case, or without running a machine yourself. Right? So I very strongly and very deeply believe that is a core essence for a core kind of necessity for fluency. The problem I see that is developing more and more is that sort of knowledge domain is obviously expanding constantly. Also, the expectation of production is expanding constantly. So, which is the dilemma of, like, I guess, glossiness, right, or finishedness. Right? So design has increasingly also been equated with kind of finishedness, or sort of a polished kind of performance. We see that in the paper presentations, we see it in the award presentations, we see it everywhere. We see it also in the devices that we use. We use devices of technology which are dominated by a sort of sense of completeness that Apple has established by creating design with like an sort of changeable perfection, which I think is completely against the idea of design exploration and actually like having a failure, having an insight, also establishing new directions, because new directions will not look polished and they will not look like they make sense, and they will probably even, in the best case, probably not even understood, right? Because it takes many takes and it takes a community to process a new approach to also establish an audience for it. We've seen that also with robotic construction, right, or the robotic kind of arms, right, which is like initially were kind of an oddity, right? And then like over the years slowly became like the desire sort of line. Everyone wanted to have one, right? And then this kind of field matures slowly and then becomes almost formulaic, right? That everyone kind of goes through the similar, what's possible within the time frame and an expertise framework, right, of such a machine, right? And then it sort of enters the domain where you need teams, we need large resources, right? And suddenly it becomes unattainable for the majority of individual researchers to compete with like teams of 30, 40 people with millions of dollars of budgets. Right? And then the question is it at that point possible to reframe what research is and also how you sort of can contribute to it, right? So it doesn't become like, let's say, the perfection of a project or its sort of monumental depth and breadth, but maybe also how to deliver a provocative idea. And that's kind of where it goes back to the selective prototype, where I strongly believe that this is a possible vehicle to make something experienceable and trigger a response. So that's maybe one answer to your question, right? So I believe in the sort of the provocation, right, of research to make people think, oneself think, through these sort of methods over, let's say, an overly polished or over sort of the large-scale kind of effort as the only possible way to operate. Between collaborative teams or individuals, I think both approaches should still have like a chance.
Mm-hmm. Thanks so much. I think you've touched upon some very crucial points that are on many of our minds as the field maturing, as you said it, and the scale of projects going up, and they basically losing accessibility to what we can do and how we can explore. I want to go back to your research in particular, in the same context. Like it's clear that you're very your interest goes beyond understanding the technical complexity of a process or controlling the complex behavior to computation, but it's really explorative. So it's less about I want to do this, how do I make it happen? It's really about how do I combine all these things that we have accessible and see what happens, which I think is really, really inspiring. And you do a lot of your work by expanding the digital with the physical and really blurring the boundaries, right, between digital physical, between design and fabrication, between machine and architecture. So less about how do we solve a problem, but what happens when we really bring these things together. Do you think one of the main problems also in how the research is going and how teaching is becoming really difficult and things becoming unattainable, do you think one problem is that we're too focused on optimizing, on searching for efficiency, on really finding solutions to a very specific problem? Are we like losing this capacity of exploring and bringing in the creativity into our research? And is this maybe a symptom of trying to become too technical and trying to go into these very technical fields and basically mimicking how science is being done in engineering or other fields?
Well, I mean, I think I would never claim that any of such approaches is necessarily wrong, because that's kind of going to the core motivation. Right? I think everyone needs something to drive their work, right? And if there's a fascination for the technical, then and that leads to a deep dive, then that's great. Right? But I would, and also I love doing that, definitely. But one thing I try to remind myself at all times is to not forget the human dimension. And I think that, if anything, is maybe like something as a critique of the technical. The technical is never non-human. Right? So we see so much of the work and also the celebration of like the absence of people because they're sort of taken out of the documentation or they're not the subject of the research, when in fact, of course, none of these projects would happen without human intervention. Right? So my claim with the embodied computation is to really always take a step back and draw the sort of boundary around the project with the inclusion of the people, the researchers, the people that are affected by the project, by the work, right? But also how we think of how we live with our technology. So that is also to push beyond pure fabrication or even presenting pure fabrication projects as pure fabrication, because they're not, right? There's still consequences on the people that operate the machines, but also the environment they're constructing and creating. So that's the sort of lift-in part of the architectural sort of research, right? So, which I try to make with the flexing room at the point that we really need to think to go beyond the sort of object-to-object relationship, which is a very deeply ingrained one in robotics. And I think we are probably a little bit adapting too much. Right? Architecture is not about creating mobile sentient machines which we interact with, but it's about environments and space and enclosures. And I think this is in part because it's a much harder problem in some regards, because we don't have as many biological precedents, because most intelligent beings are objects. Right? So we know how to interact with them from our own human experience, but we have much less sort of precedents of interacting with a building, a room, and also the challenges of collective interactions. Right? So if a building contains 1,000 people, how do you interact? Right? So that's the sort of notion of body language of a building, right? Not in the anthropomorphic sense, but what is the language of a structure that interacts with many entities that are within it at the same time. And this is sort of often stuffed into the bag of smart buildings and like building automation, right? But it is not, right? It's a social phenomena. It's ultimately what our lived environment is, right? And I think we need to sort of, embrace that, right? And not sort of put things too much into categories that are separated. Right?
Absolutely, thank you. We do have a question in our Q&A, and I think it relates very nicely to your first response to my first question. So Vernell is asking, how do we balance who has resources and who doesn't have technological resources when it comes to research and publication of research in our field? That's a hard one.
That's like I said before. I mean, I think all approaches are valid ones, but I think it's about appreciating on also creating a framework in which non-resource heavy contributions are honored and appreciated and have a platform. And that's the sort of last comment in the talk with the platform building. And also, I think to not confuse productivity with provocation, and thought-provoking kind of work. So there's a danger that infrastructure and also, let's say, the almost industrial implementation of thought through APIs and reuse of libraries and also software environments and pipelines produces a distortion of the actual intellectual sort of production just by sheer mass and quality of output. And quality being, in this case, in a certain vein, right? You create peaks of output where it becomes very, very difficult in a different vein to compete with that type of volume and quality of output if your thought does not rely, or your process does not rely on the same pipelines. And that can be, yes, a resource established pipeline through labs, through machines, through personnel and infrastructure, but it can also be on a less infrastructure-based, like an implementation, right? Let's say in Google API or like certain sort of mainstream industry standards, right, allow you to produce very quickly, very robust things, right? But maybe a critical different approach that has not been implemented since the 80s or 90s or even created from scratch, right, will require much more sort of ground up building and hence less production and productivity in that domain, right? So I think we may need to think about also in publication and research to create categories which are sort of from scratch. Theoretical implementation models, right? And I don't mean theory meaning not implemented, right? But to acknowledge that it's a new approach without the infrastructural support that should garner interest and also review and discussion, and to be given time to develop. Because the problem is if it's drowned out by production, by other sort of approaches, it will never get the actual chance to develop. And long-term, the most provocative and interesting ideas and projects are always the long tail ones, right? So that take 10, 15 years, right? Including the ones that are currently mainstream, came from very humble and small beginnings. So we need to protect those. I think we, meaning not you and me necessarily, right? But as a collective, remind ourselves, how can we achieve that such thoughts and humble beginnings, so to say, don't get lost.
Is it about more fundamental research that you think we should encourage as opposed to the very applied research that is happening a lot in our field, or is it less about the type but more about providing the space and the time for people?
Yeah, or also just, I mean, different people have different sensibilities, right? Yeah. So I think it's also the ultimate diversity question, right? So if I encourage somebody to do that, it will invariably reflect my biases and my preferences and my upbringing and my abilities somewhere. Right? But if I sort of let a more open-ended kind of platform evolve in which other voices, also things that may be uncomfortable or unfamiliar to me, give them time and space to develop, I think then we will have more interesting diversity of thought and approaches a few years down the line. Right? So I think this is absolutely crucial, and of course a sort of really difficult dilemma, but it ultimately means to bring in support and actively encourage students in teaching, and also not yet students, right, to enter the field with alternative ideas and approaches, even if it means it's directly contradicting what my own value system at that point may be. So I think this is the hardest part, right? How do you spot a novel approach if it isn't within one's own quality or reference framework, right? And this goes to the whole academic pipeline. This goes to communities as a whole. And I think ACADIA is also such a community, of course. Like how do we make sure that people are not alienated by what they see, right? But see a spot to test out and sort of provoke with different approaches and ideas.
Yeah, I mean, it's such a challenging question or problem to think about, because at the same time, we as teachers and researchers, I guess we think a lot about knowledge transfer. How do you get students and researchers up to speed with the available resources as quickly as possible so that they can produce things, and then just like actively pulling the brakes on that and giving the time and space. I think this would be fantastic to be able to do that. Probably a bigger question about the academic system and what sort of output is being supported and what is being asked of academic researchers, and how to make that space. I don't think we have the answers to this, but it's really a big conversation that I hope will continue in some way. Maybe another point, and you've already touched upon it, but I think the way you finished actually your presentation was really talking about increasing diversity of culture through the different media that we work with, that maybe the traditional way in which we do design and construction doesn't really offer. I'm wondering specifically if you can think about other ways or ways in which computation can really enhance this increase of diversity. You've talked about platforms and about giving the space and the time, which I think is really crucial. I'm wondering whether the fact that we include more and more technology and more complex technology, and we go deeper and deeper into these topics, actually makes this type of knowledge less accessible to different students, researchers, participants in any way, and if there's things you are thinking about in that direction, how can we make that gap actually smaller, and more accessible for everyone?
Well, I think one is different ways to learn. Right? I mentioned that briefly before. Right? So that's, I think, the community effort of documenting approaches, which are impossible to reproduce in any one particular individual teaching. So I think this has also led to a fundamental shift in knowledge acquisition in the academic context over the last 15, 20 years. Right? From one of more of a gatekeeper type of situation, only here can you learn about this, right? This is the only place this is produced or is accessible, right? To much broader kind of channels and also different voices. But I think on the other hand, also that is it's super crucial to identify a reason why you want to learn. I think this is sort of this is the, I think, most important aspect to kind of get down to the bottom of why a student would be or could be interested in diving into a select sort of path, right? Through this essentially not quite infinite, but close to infinite set of knowledge kind of challenges of learning. So to create some sort of a compass for help students and also ourselves, like to find a compass to select and sort of selectively learn, but also then have hard challenges that do not go away. Right? And that's, again, to resist the productivity or production kind of temptation. Right? So it is an easier path to follow, of course, one that's already been blazed before, right? And it will look more successful. Right? But if the motivation is actually requiring a different approach, a different library to be developed, a different computational model that isn't existing, right? Then you need to basically support and also yourself, like hammer away at that problem, even if it means it slows you down or may even mean you'll get delayed in your expected output. Right? So I think that compass is really crucial, also with regards to the sort of bigger problems that we're facing, and also the problems that drive individuals, right, from their individual backgrounds, which oneself may not understand. Right? But I think we have to be sensible to, basically be aware of, right, that they may exist.
I mean, it's kind of, I'm asking you these questions as if you had the answer to all of this when, we're all in the position of trying to get things done. But no, I keep thinking for myself, like, how do we make the space to allow really for explorations for maybe really taking the risk that you might not get an output at all. How I wish there was an answer to how can we make this possible in the context where output, publications, quick turnaround is just really what is being asked from us. There seems to be like exactly the opposite.
Yeah, I mean, it's also different categories, I think, right? Like, I mean, certain high production and high intensity projects only reach a certain level of criticality at that institutional scale, et cetera, right? So I'm not at all dismissing that as so it is absolutely necessary, but it should be always emphasized and be possible to establish a small scale and sort of fragile alternative approach, right? And not compare them per se as better or worse, right? So I think it's a way to, basically also I think it's a question of metric, right? How do you actually measure, or how do you evaluate this, and also how you create incentives for such projects to be started and be acknowledged, right? So it's a bit like a competition in architecture, right? If you make the competition hyper specific in its programmatic needs, et cetera, stylistic preferences and budget, et cetera, you're likely going to get pretty much exactly that for most of the contributions, right? If you make it completely open-ended, it may become so vast and distributed in its quality that it's almost useless, right? But somewhere in this, there's a sweet spot, right? Where you may actually get an open-ended kind of competition where new ideas really provide like a different approach, right? And then also get acknowledged for that, right? So my one famous example, I mean, not favorite example, is sort of the high-speed sailing open-ended speed record, right? Which is a completely unrelated sort of thing, right? But there you have just a very simple metric, which is how fast can you go with wind and water. And if you look at the range of outcomes from, let's say, the smallest sort of vessel to the sort of biggest boat, right? And the different sort of backgrounds and financial sort of abilities of those competing, right? It's really staggering how, let's say, productive such an open-ended kind of framework can be. And let's say in design and architecture, I'm constantly looking for how one could kind of create more open-ended sort of, invitations to contribute ideas that lead to a similar kind of breadth of productivity, and not a metric in terms of performance criteria like speed or something like this, but sort of open-ended thought. That's ultimately what's at the sort of core of interesting and impactful projects. So.
Fantastic. I do see Jose Luis coming in soon. We are running out of time. Unfortunately, there was another question in the Q&A. If you have a minute, take a look at it. Maybe feel free to answer either in the chat, or maybe if you feel like joining the networking session. But thank you so much. Thanks a lot for the talk and the really inspiring conversation. Congratulations again, and it was fantastic.
Thank you. Thanks, Stefano. Also, and to ACADIA, everyone. Thank you.
Thank you, Axel. It was a pleasure. Thank you, Stefano, for conducting this panel. I would like to wrap it up with a couple of reminders. We are going to move on into the next session in about 15 minutes. It's going to be the last paper presentation session of the conference, I believe. So please join us in about 15 please join us in about 15 minutes for the paper presentation. And in the meantime, you're welcome to join us on the networking rooms and in the social events. All right.
To begin by thanking our sponsors and the ACADIA community for making this event possible. This session is being recorded and will be available to registered conference attendees for viewing after the event. Conference attendees are welcome to use the chat interface during the event, but we ask that you remain respectful in your comments and observe ACADIA's code of conduct. If you have specific questions for the presenters, please use the Q&A function. Thank you for your cooperation, and we hope that you enjoy this ACADIA 2021 session. I am absolutely happy to kick off this paper session with the theme Emerging Design Approaches, which will be chaired by ACADIA 2021 co-chair Behnaz Farahi. Trained as an architect, Behnaz is an award-winning designer and critical maker based in Los Angeles. She holds a PhD in Interdisciplinary Media Arts and Practice from USC School of Cinematic Arts. Currently, Benaz is an assistant professor at the Department of Design, California State University, Long Beach. She explores how to foster an empathetic relationship between the human body and the space around it using computational systems. Her work addresses critical issues such as feminism, emotion, perception, and social interaction. Farahi has won several awards, including the Cooper Hewitt Smithsonian Design Museum Digital Design Award, Innovation by Design Fast Company Award, and the World Technology Award. She's a co-editor of an issue of AD, 3D Printed Body Architecture from 2017, and Interactive Futures, forthcoming.
Sorry, we are not.
Vernel, we went off.
Wow.
Yes, so I'm going to stop networking, all right? And then I'm going to press go live.
Okay.
You start.
So where do I start back from?
You start back from Cooper Hewitt Award.
Okay.
And give yourselves, when I go live, give yourself like 10 seconds for people to. I'm watching on my side when it goes live. I'll give you a thumbs up.
Okay. Okay.
Seriously.
Okay, so it came up.
All right, it looks.
You're live.
Wait, but still not.
Okay. No? Okay. Benaz has won several awards, including the Cooper Hewitt Smithsonian Design Museum Digital Design Award, Innovation by Design Fast Company Award, and World Technology Award. She is a co-editor of an issue of AD, 3D Printed Body Architecture from 2017, and Interactive Futures, forthcoming. She's an amazing co-chair, and we look forward to her chairing this session. So I'll now hand it over to you, Benaz.
Thank you so much, Vernal. Hi, everyone. So our session on emerging design approaches features 4 amazing papers and projects which address the notion of participatory design, affective computing, spatial computing, and physical computing. These papers together offers us some very interesting insights to emerging trends in design and computational design in general. So first of all, I have to say that my apologies for mispronouncing names, but I'll try my best. The first paper is Aligning the Analog, Digital, and Hyperreal Software Errors as Design Exploration Driver by Malgorzata Zubinska and Olivia Romert. The second paper is Architect, an accessible tool for the democratization of architectural design by Anna Mitchell, Nicholas Bruscia, and Cody Major. The third paper is Topological Network using a Sequential Method, participatory community design based on mobile interfaces by Zidog Liu. And the last paper is Affective Matter and Sensorial Interpretations of Covered Physiological Signals for Therapeutic Meditation by Catherine Richard Lin and Jose Luis are co-chairs of the conference, which I have to say this last paper I'm excited about because also my PhD thesis was affective, emotive matter. So extremely excited. With that, now let's watch all the presentations.
Hello and welcome to the presentation for Aligning the Analog, Digital, and the Hyperreal Software Errors as Design Exploration Drivers. This research paper is written by Malgorzata Zubinska and myself, Olivia Romert. This work explores the relevance of software-generated errors for contemporary architectural design. By exploring the errors of photogrammetry specifically, we sought to highlight its potential as a creative exploration medium instead of a mere representation tool. According to architect John May, the modern architectural drawing has been replaced by a digital image. The pixelated representation no longer bears any resemblance to the traditional drawing and needs to be studied within new conceptual frameworks. One such framework that challenges the value of the image can be found in the theoretical work of the late French cultural theorist Jean Baudrillard, who suggests that we live in a time of hyperreality. According to Baudrillard, there are 4 orders of the modern image. These orders range from an authentic reflection of reality and ends with a hyperreal image with no connection to reality. Whereas Baudrillard's theory predominantly concerns the 2-dimensional image, the aim of this work was to explore it in the context of digital architectural design in 3 dimensions. More specifically, to coin how employing Baudrillard's 4 orders of the image to define the phases of a digital 3D model's error manipulations affected architectural qualities generated in these phases. Method. The design exploration was divided into 7 phases. The diagram on the right on this slide shows how Baudrillard's order of the image relates to the phases of the exploration, while the diagram on the left describes the overall process. And by completing the process in 7 phases, the same theory can be applied to the model originating in reality as to the model derived from hyperreality. And as shown in the diagram, the first order of the image applies to both the first and the 7th phase of the project, enabling their critical comparison. The second phase is applied to the 2nd and the 6th phase of the project, and the third order is applied to the 3rd and the 5th phase of the project. Once at phase 4, the process is reversed, and it is also here that we achieve the hyperreal model. To carry out the investigation following Baudrillard's order of the image, 2 existing buildings were chosen as subjects of our experimental design inquiry. The building on the left in this slide was originally named the United Kingdom Hotel, and it was constructed in 1937. The architect for this project was James Wardrop. And the building was selected for this exploration because of its characteristic Art Deco features. To explore the robustness of the proposed method, an architectural element from a contemporary building was also included, namely the RMIT University building, number 22, designed by ARM Architecture. Its double curved awning was chosen for its striking material representation of the Penrose tile. And this representation appears above the entrance as well as on the building's roof level. And the aim of this introduction was to explore how an element with a strong contemporary expression could enrich the transformations of the existing building. Design explorations. So according to Baudrillard's first order, the image is the reflection of the basic reality. This means that the image is faithful and, according to Baudrillard, a good appearance. In this first phase of the process, images were taken from various angles around the United Kingdom Hotel. The documentation was carried out using a mobile phone from ground level, and this intentional restriction of the photography setup generated errors that influenced the explorations in the following phases. In the second order, the image masks and perverts a profound reality. And this is, again, according to Baudrillard, where we come to believe the image to be an unfaithful copy, which masks and denatures reality. In this phase, the images captured in phase 1 are compounded into a 3D model using photogrammetry software. On this slide, some of the misinterpretations that were made by the software are made visible. You can, for example, see that the denseness of the mesh varies across the model. In some places, it's rich and captures detailed textures and outlines. And in other places, the information is insufficient, and the software has made some estimations that do not reflect reality. And in the same manner as for the United Kingdom Hotel, the awning of the RMIT University Building 22 was captured with the intention of evoking photogrammetry glitches. The images were captured from a frog perspective underneath the awning, causing the software to interpret the awning as a curved, very thin surface with a rough texture, when the actual object is voluminous, planar, and very smooth. And this becomes extra evident through the section on the right in this slide that illustrates the thin, rugged surface. In the third order, the image masks the absence of a basic reality, and the image pretends to be a faithful copy, but it is really a copy with no original. And this relates to the third phase of our exploration, where 4 details from the United Kingdom hotel were modified to the point where they developed new architectural qualities. For this phase, visual coding was used to modify the elements. These modifications included changes to the mesh and the mass, as well as tracing as a form generator. These images show the outcome of the modifications made to the tower element specifically. And in the fourth order, the image bears no relation to reality whatsoever, and it is its own pure simulacrum. The overall intention of this phase is to create a hyper-realistic counterpart of the existing building. And this is done in 2 stages. And in the first stage of the exploration, individual components' spatial qualities were studied as isolated objects. And by doing this, the objects were liberated from their predefined functions and expressions. The components were then joined, and the elements were then assembled into a new spatial and functional configuration, acting as a hyperreal counterpart to the old United Kingdom hotel. And it is in this phase that the process is reversed. So we are entering phase 5. So in this phase, the hyperreal model is split into separate elements and assigned with physical material. And this phase examines the gap between what appears to be real and what appears to be exaggerated and false. In the second last phase, elements from phase 4 and 5 were applied to serve 2 different purposes in the model. In the first instance, elements were applied to serve a reparative function, and secondly, elements were used as a design option to an existing part of the building. These additions include sunshades, facade details, and other elements that may not have been needed at the time of construction, but could complement the contemporary building's functionality. And in addition to this, the contemporary element derived from the Penrose pattern, namely the green awning, was applied to part of the roof structure which lacked information. The awning was rotated and multiplied with the intention of creating a form that appears to cascade off the roof. The element is also intended to boost the aesthetic and form with an addition derived from another stylistic period. And in this last step of the process, the model resumes its initial representation form, the photograph. The theoretical work of Jules Baudrillard has proven to be a robust conceptual scaffolding on which to base this project. But it is not until this phase that we are able to review the original claim that a highly transformed hyperreal image carries no value. In addition to Baudrillard's theory, this exploration has also included the contrasting discourses of Gilles Deleuze and Valerio Olgiati as a mean of testing the theoretical robustness of the exploration. Whereas Gilles Deleuze's interpretation of Urbanism, which implies that true value and novelty reside beyond the spatial dimensions of the existing, in the transcendent dimension of what could be, Valerio Olgiati argues through his idea of non-referential architecture that the hyperreal establishes its higher value by the lack of referencing to the prior and the existing. And this underlines the value of especially phases 4 and 5 of the presented exploration. We conclude this presentation by proposing that photogrammetry errors, although distancing the digital representation from an accurate depiction of analog reality, do not deprive it of new meaning. Conversely, they generate new aesthetic, spatial and functional qualities that uncover alternative critical ways of architectural creation. The proposed approach increases the designer's capacity to critically re-examine the current use of digital media in architecture. And by understanding how the misinterpretations between the software and reality come into being, enables us to make informed decisions about how they could serve as a design exploration medium. In the future, this approach could be relevant in architectural restoration, refurbishment, and reconstruction projects involving new digital technologies. It would provide new critical insight into the ongoing debate on new interventions and the mode of reference to existing or bygone architectural qualities. Features of existing buildings could be maintained through new form, function, and expression. And this can be done via critical, unorthodox computing, marking the genuine traces of the post-digital era. Thank you for listening.
My name is Anna, and my topic is Architect, an accessible tool for democratization of architectural design. The concept of mass customization and design democratization in architecture first appeared in 1960s-70s with the work of Jona Friedman and Nicolas Negroponte. Both argued that end users are capable of designing their dwellings without supervision from architects. Today, the general public experiences ever-increasing access to advanced technology. Local production and high individualization of output can easily be achieved without substantive cost increase and logistical delays. However, most people are not ready to take an expanded role in design due to a lack of design literacy. In mass customization, the end user is included in the process of creation by defining, configuring, matching, or modifying their individual solution from a list of options and predefined components, and the Sure customization tool is a good example. Mass confusion is the main obstacle for spreading mass customization in house design. Existing applications, such as Interactive Home Designer and BuildX, allow end users to be hands-on in the design of their homes. However, non-architects often find it difficult to understand the language of architecture. Therefore, such applications have become yet another tool used by architects and designers instead of the general public. Based on the wide popularity of computer games such as Sims and Minecraft, one can say that the public is indeed very interested in house design. In order to overcome user confusion, it is important to explore how sandbox genre games makes the practice of design accessible to non-architects. Entertainment is the main purpose of games, but not the only reason people play. When we think of games, we think of fun. When we think of learning, we think of work. Games show us this is wrong. If several built-in games can be located within the circle of fun, each will have its own specific definition based on the game's objectives. Some are restricted with regards to design variety, but easy and relaxing to play. Others may be learning games, such as SimCity, that provide fun experience by guiding players to resolve problems, solve puzzles, and master strategic thinking. Guy explained that players who enjoy such learning games are motivated by a pleasantly frustrating feeling, which keeps them playing because they feel that challenge is difficult but doable. Interface inaccessibility for non-architect users and limited freedom with regards to design criteria like case current customization tools outside of the fun circle. The Architect game is an accessible pedagogical tool designed for two players. This work explores the idea that those with no background in design can still learn basic architectural principles by playing a game and improving their design intuition through the iterative process of trial and error. Players must download and print out the tabletop portion of the game from the Architect platform and install the Architect application, allowing for a mixed reality experience. The game consists of 3 levels: tutorials, challenges, and the sandbox. Each level utilizes room playing cards and series of playing boards. Every playing card has a name, budget, value, and additional features such as mirror, coupled with a 2D representation of the conventional architectural plan. Each playing card and board has an Aruka code that is programmed to transform a 2D drawing into a 3D model in hologram application. To design a house, one needs to understand basic design principles and interdependencies. The game begins with a tutorial intended to familiarize players with the AR technology and introduce the game mechanics. The tutorials guide players through the rules of room aggregation and explain how to interpret the game's feedback. The game connects the notion of budget limitations to room juxtaposition. For example, a player may need to combine 2 rooms for communal use, as not to exceed 5 budget points. Also, feedback helps with evaluating the juxtaposition of rooms as correct or incorrect, as represented by a green or red glow. The game also gives the player the option to control windows and doors placement and their quantity through simplified Boolean operations. Other tutorials are devoted to learning and visualizing the implications of orientation, which is achieved by changing the north card from north at 90 degrees to north at 45 degrees. And exploring the influence of time on interior qualities by simulating the sun and visualizing shadows. Additionally, by scaling the house, players can experience their designs from different viewpoints, ranging from the aerial view perspective to the first-person view. Challenge set objectives are designed to allow users to revisit concept learning in tutorials and practice design problem solving through role-playing. Context playboards with preset design inputs become playgrounds with different levels of difficulty. At the beginning of the challenge level, players randomly choose their roles. One becomes an architect and the other a client. The latter takes a random family card that lists specific requirements. By choosing options, reaching a consensus, and making informed decisions, players simulate architect-client communication and iterate concepts from the tutorial set, but within a more advanced system of constraints. For example, a client may receive a family card of Vampire Family 3. During each round, the architect goal is to help the client to formulate their needs and preferences and provide them the best design solution out of 3 house design options. After every house option, the client takes a drama card from the pile. The goal of the drama card is to shift the narrative in a particular direction that forces the architect to provide an alternative solution. Drama cards may have positive, negative, or neutral connotations. One drama card requires that players swap roles, allowing players to experience both roles and learn the same concept from different angles and set of responsibilities. Architect endeavors to become a new participatory platform for house design democratization. The sandbox gameplay represents this effort as an avenue for future development. Players can find the actual sites via geomap and websites like Google Earth. They can convert them into plane boards and print them out. By following the same logic for design and self-evaluation for AR application, players can iteratively design houses, convert their designs into 2D drawings, and use the aggregated models to 3D print their house designs. The learning by playing approach has immense potential to open up architectural education to general public. The Architect platform will contribute to creating generation of collective design effort, resulting in projects that architects could not produce alone. Players will be able to share their designs, ideas through the resulting open source architectural culture, leading to user empowerment, design democratization, and the proliferation of design literacy. Several in-person playtest sessions were conducted as proof of concept. Non-architect players tested the game 3 times, while others were exposed to game only once. All testers, except for one, had no architectural background and explored Architect via the hologram application for 1 to 1.5 hours per session. The first session with 2 players showed the importance of game structure. During the first session, the game was tested totally by an architect. After completing the tutorials and challenges, they began to play the game at the sandbox level. In contrast to previous players, the architect revealed new game potential by creating various room juxtapositions. Also, the player utilized the AR application in a more dynamic manner to better understand the relationships between rooms and context. The architect concept challenges the conventional approach to design participation and eliminates the architect as a primary part for translator of end user's vision. The absence of the win state, as well as absence of a single correct design solution, unleashes players' creativity and provides a new approach to house design. During playtesting sessions, non-architect users showed unique collaborative engagement, as participants learned to design ideas and interdependencies not only through the narrative, but also through role-playing. This experience prompted the research endeavor to explore other aspects of player-on-player interaction and the ways a game might enhance and support the learning experience for communication and informed decision-making. This served to call into question more traditional ways of learning, instead promoting AR technology for new educational engagements. Architect requires further development of the game levels and additional playtesting experiments with a larger body of non-architect users in order to depict more comprehensive conclusions and discover controversial topics for discussion. In future iterations, a new project participant role of the city with more code-related constraints will be included, providing additional didactic guidance and allowing more individuals to participate. Substitution of hologram for the original architect applications is also needed to eliminate use of Aruku code. The goal of architect is to spread design democratization through an accessible and playful educative experience, bridging the gap between experts and non-experts. The game should be played by friends and family members, providing a new option on game nights. Additionally, architect invests in common architectural knowledge as a body of thought that can be utilized in architectural schools, allowing students to explore their workflow by creating other modules for single-family housing. Therefore, the notion of design democratization extends not only to the public realm, but also to institutions of higher education. By democratizing architectural education through playful and engaging experience, architect opens up new sources of architectural thought that will allow the collective intelligence to move forward and invite non-professionals to the table. Thank you.
Hello everyone. Today I would like to share the preliminary result of a sequential approach for data structure simplification in topological network for interactive design. I am Zdonio. I graduated from Bachelor at UCL in urban design and hold a Bachelor of Architecture degree from the Southeast University in China. In addition, I spent half a year as an exchange student at Polytechnic di Torino. My research interests focus on spatial network-based generative design, urban analysis, and machine learning-based urban feature prediction. Now I am looking for a PhD position. The research aims to explore a sequential approach to organizing the topological network. Sequential method means that, in some cases, the spatial network of buildings can be approximated as a collection of sequences. In this research, the approach is applied to building an interactive community design system in an app called Housing Prime. In interactive generative design, a common problem is harnessing the topological network formed by user demand information. After data connection, user information is transformed into two parts, topological and geometrical. If designers set too many parameters in collecting data, they face a complex network that is hard to be directly geometrized. Therefore, the method to analyze and reorganize the topological network for data distribution is significant. The research on architectural topological design has a decades-long history. The spatial syntax team developed a systematic method of spatial network analysis, revealing the connections between spatial network and social logic. The rapid development of network science provides an increasingly rich set of tools for spatial network analysis. These studies strongly support the development of architectural generative design, especially in layout automation. The sequential method means interrupting the topological network from the perspective of activity sequence. In some projects with distinct circulations, the spatial network can be approximated as the collection of activity sequence. The sequence acts as an intermediate hierarchy to cluster nodes and form the system. The Seoul Museum is a classic case of using sequential approach to organize flow layout. It serves multiple functions simultaneously within a narrow interior space. Family life, party, art making, teaching, exhibition, and so on. Besides, due to the historical background, people with different identities had their own specialized paths, such as the specific logistics circulation for servants. Sir John Soane used a narrative approach to organize these various life patterns. The topological analysis of space reveals that the structure of network is composed of interwoven sequences. The sequential approach has the potential to be applied to the community design as well. Today's community design is faced with the similar design problems as the Seoul Museum. Complex functions, interwoven circulations, customized living patterns, and adaptability for flexible use. In the paper, the sequential approach is demonstrated with a community design experiment aiming at housing customization and community self-organization. This work is part of Housing Prime, a research project of RC11, Wipro the Bartlett 2020, led by Philip Morrow and Paul Point. Here is the user interfaces of Housing Prime app. An interactive platform based on a mobile interface is built on the front end for user data connection and design result preview. The process of transforming topological and geometric information into community design is carried out in the back end. The entire generative design system consists of 3 parts: site selection, community design, and housing unit design. This research focuses on sharing the result of community design part, where the sequential approach is mainly used. This experimental design is based on data from 200 simulated users. To maximize system complexity and verify the effectiveness of the sequential approach, each virtual user data is completely renderized. After data collection, these mixed-up user demands will be translated and redirected to the different parts of the generative design system. The data about the community design is the most complex one, because the type and the number of shared rooms and community facilities for each user are different. Due to the limitation of computing power, it is impossible to input 200 users' data at the same time for generative design. Therefore, the virtual 200 users are classified into 20 living clusters. The pairing process is based on k-means clustering algorithm. In this algorithm, each resident is regarded as a piece of 3-dimensional data. The weighted approach is used to distinguish the importance of different attributes. People living in the same cluster share the similar living patterns and infrastructure demands. For example, they might take a walk in the community park after work and then exercise at the community gym before returning home. We regard such a life pattern as a type of activity sequence. Suppose there are 10 users from A1 to A10 who have personalized needs for 4 facilities: office, study room, kitchen, and living room. These demands form a complex network that is difficult to geometrize. After clustering the users, we find that A1, A2, A4, A6, A9 are considered as a living cluster. The remaining 5 users and facilities form another sequence. It should be noticed that this classification is only an approximation. For example, we ignore the need of A3 for offices. We need to provide a common sequence connected to the public transport network, which facilitates the resident to access other places. Based on these rules, 200 users are divided into 20 clusters and generate 52 activity sequences. We use the physics engine to set the design constraint. This approach has been widely used in generative design in the past. Elements along a sequence have rotational forces, Fd, to keep the angle between them at 0 or 90 degrees, thereby keeping the layout structure orthogonal. In the process of generating the layout of living cluster, highly matched living units will have an attraction in the middle, otherwise they will be mutually exclusive. Physics engine can only roughly simulate the relationship between elements because the results are very easy to be affected by the initial position of the element. In order to overcome this uncertainty, genetic algorithm is used to optimize the result based on the specific performance index P. Here, we optimize the result by minimizing Ln and maximizing Bn. After getting the topological information, the system will automatically generate the details for living cluster. Then there will be a process of flaws aggregation, and the system will automatically generate the circulation. We apply the same genetic algorithm for three-dimensional optimization to get a more compact plane. Based on 200 users' data, the prototype system presented in this paper obtains a community design result with diverse architectural space emerging. In this generative design process, the sequential approach creatively translated the individual demands into different life patterns, successfully reducing the complexity of the problem. At present, the system is still in the preliminary explorative development. In the process of simulating the sequential network, we have found that the traditional physics engine simulation requires considerable refinement due to the instability of the result. In conclusion, this paper verifies the effectiveness of a novel sequential approach in organizing topological network in generative design process. The importance of sequential approach is that it provides a novel and effective tool for designing complex network. Architects and planners have developed various methods to analyze an existing complex network, but how to create complexity remains a daunting task. Sequence is a new perspective for people to control complexity. As a bridge, the sequence powerfully connects the mathematical topological network with the vitality of individual human patterns of life. Thanks for your listening. Please reach out to me if you have any questions or want to discuss further. That's all. Thank you.
Hello, everyone. My name is Katrina Richter-Lunn, and I'll be presenting my paper, Affective Matter, Sensorial Interpretations of Covert Physiological Signals for Therapeutic Mediation. This work is co-authored by Professor José Luis García del Castillo López and executed at the Harvard Graduate School of Design in Cambridge, Massachusetts. Although there is a number of crises that occupy our world today, all of which are extraordinarily important in balancing our ecosystem, mental health disorders, stress, and anxiety remain among the leaders of these crises, impacting every individual, regardless of their geographic location, socioeconomic background, gender, or race. Due to my own struggles with stress and anxiety and the number of people close to me who suffer from similar strains, I've made it a personal goal in my work to investigate how, as a designer, architect, and technologist, I can address this pressing issue in our world today. It is with this ambition that I embarked on this work, which seeks to demonstrate how human, machine, and sensorial interactions can be leveraged via effective computing to propose more seamless, accessible, and amiable solutions for addressing mental health. In order to give you an overview of the domains in which this paper lies, I have divided my research into 3 main categories: psychophysiology and embodied cognition, sensory environments and design, and effective computing and human-machine interaction, which, as you can imagine, all have a great deal of overlap and influence on each other. Starting with psychophysiology. There's a huge number of ways in which we can start to collect physical and neurological information, which can inform us of various cognitive and emotional outcomes, all of which provide different layers of insight. However, for the purpose of this research, we focus primarily on electrodermal activity and heart rate variability in communicating an individual's cognitive state. For those who are not very familiar with these terms, here is a very, very brief overview. Electrodermal activity, otherwise known as EDA, represents the changes in the electrical properties of the skin, previously called galvanic skin response and used in lie detecting machines. EDA is modulated by the sympathetic branch of our autonomic nervous system, otherwise known to control our activating or fight and flight responses. And then there's heart rate variability, also known as HRV, which represents the variation in time between your heartbeats. Unlike EDA, heart rate variability is controlled by both branches of your autonomic nervous system, your parasympathetic and sympathetic, and essentially gives us an idea of the level of communication happening between these 2 branches. So if variation is high, this indicates good communication between both sides and a healthy nervous system, while low variability shows association with stress, anxiety, and depression. So you might ask yourself how we are collecting all of this data. In this research, we are using the FDA-approved E4 wristband from Empatica. It measures a number of different physiological signals such as EDA, heart rate, body temperature, movement, and blood volume pulse, and has allowed us to continuously and passively track all of this data longitudinally and in quote, the wild. So here is a highly personal snapshot into 5 days of my life. Sadly, not too extraordinarily exciting, I'm sorry, but you can quickly identify where levels of EDA seem to rise the most. Interestingly, sleep shows consistent spikes in EDA throughout the night, which is a little bit of a hot topic in the world of sleep research right now. But other than sleep, you can see patterns of EDA related to meetings, exercise, and social interaction. But even more interesting, in my opinion, is when you look at this data in correlation with other physiological metrics, such as movement, skin temperature, and heart rate, since it can start to give you a better idea of why these spikes might be occurring, and also allow you to apply conditional statements to avoid false readings of stress and anxiety. So now that I've covered a brief overview of psychophysiology, I would like to touch on sensorial response. In order to suggest a possible methodology that explores our sensory perception, we must first look at each sense in isolation and the range of cognitive impact each of these senses hold on mood and emotion. In this work, the senses targeted are haptic, olfactory, visual, and auditory. Haptic, for example, has been studied as a strategy to soothe individuals. Methods include light pressure, temperature, and vibration. Auditory has been primarily explored through the lens of translating biometric data into sonic interpretations for both the performative purposes and increasing self-awareness. Vision, one of the noblest of our senses and historically considered the most dominant. Many studies focus their research on the impact of light in relation to attention, focus, and tranquility. Lastly, there is the sense of smell, perhaps the second most pervasive sense after vision. It's both a powerful tool in influencing mood and behavior, as well as highly personal. Lastly, we'll take a quick look at the field of effective computing and human-machine interaction. Historically, the field of effective computing has primarily looked like this, with a focus revolving around software applications which collect, process, and interpret various data to assess a person's affective state, and in turn respond empathetically, emotively to the user. However, over the past few years, we have seen the field expand outside of simply software applications and devices to areas such as wearables, which react both passively and actively to our body's movement, temperature, and surrounding, to active and programmable materials, which when actuated change and transform based on their innate material properties, to social robotics, where the communication between human and robot no longer is a linear process, but rather a conversation. And finally, we see effective computing filter its way into full-scale exhibits and installations, which showcase intimate information through artistic renditions and immersive environments. All of this to showcase that with the power of today's technology, scientific advancements, and design sensibility, we've been able to push these fields to new extents through the interdisciplinary overlap that occurs between them. It is in this overlap where we would like to situate the work and the methodology followed for the design interventions. I will now present to you 4 pieces which investigate a different combination of sensory experiences, which respond to specific physiological signals. Each of these pieces follow the same closed loop system. Starting with a human, a collection of their raw physiological signals are collected. This data is then analyzed and assessed to be linked with a certain emotional state. This interpretation then actuates a specific desired sensorial output, which in turn influences the human through their experience of that stimulus. The first piece we would like to introduce explores both haptic and auditory sensory stimulus and sits intimately on your wrist. This piece looks specifically at interpreting patterns of EDA and heart rate variability to recognize signs of stress and anxiety, to in turn pneumatically actuate silicone pockets facing the interior of the wrist. These air pockets seek to mimic slow inhale and exhales both auditorily and haptically, to soothe and bring embodied awareness of one's cognitive state. Additionally, the slight pressure felt by the piece adds another layer of haptic comfort through the mimicked feeling of being held. This multi-material piece inlaid with 2 soft silicone pockets inflates through plastic tubes connected to an air pump and microcontroller. When signs of heightened EDA and low heart rate variability are detected in unison, the pneumatic system is deployed. Once activated, the pump follows a slow graduated breathing pattern, namely a 4 seconds inhale, 7 seconds hold, and 8 seconds exhale. The second piece, much like the first, looks at haptic guidance, however, this time with no auditory stimulus and in the form of soft vibrations rather than pressure. The haptic chair attachment detects heightened and low levels of electrodermal activity, signaling an individual's level of emotional arousal in conjunction with motion gathered from an accelerometer. Observed in parallel, this data can illustrate correlations between prolonged periods of low movement and decreased focus and restlessness. In response, a series of 20 vibration motors lining the fins of the piece actuate when signals suggest either a state of restlessness and agitation or drowsiness and decreased focus. In response, the haptic guidance system emits patterns of soft vibration, which gradient in power to again mimic the 4-7-8 breathing technique explored in the wrist piece, with the primary goal being to mitigate extreme emotional states through passive and embodied techniques to in turn influence our autonomic nervous system. The desk attachment looks solely at olfaction and the power of scent diffusion for focus and relaxation. Similarly to the chair, this piece looks to measure the edge conditions of emotional arousal, which in this context, which suggest either decreased attention and sleepiness or an increase in stress. Based on literature which found that low levels exposure to the aroma of peppermint enhances aspect of cognition and mood, and that lavender oil promotes calmness in stressful scenarios, we have proceeded in using these 2 aromas for this piece. Devised of a multitude of layers, this piece consists of a 3D printed rib structure which wraps around the desk, and thanks to a thin layer of nylon placed over the top of the piece, has the dual capability of being used as a mouse pad. Underneath its structure lies 100% cotton embroidered with 40 gauge nichrome wire with 2 discrete paths to represent 2 separate heating systems. These paths directly correlate to the openings in the 3D structure, which act as chambers to house the specific scent to be activated. Hydrogel infused beads sit between these apertures, carrying either the scent of peppermint or lavender. Thanks to their thermally sensitive properties, the hydrogels increase their solubility when temperatures increase, resulting in a release of the scent-infused liquid through evaporation. Depending on the physiological signals received, a certain heating path will be deployed, resulting in the activation of one of the 2 scents. Lastly, I will present the light attachment, which focuses its capability on tempering the quality of the light which the bulb emits, to in turn cater the emission of brightness based on the needs of the individual. With a number of precedents illustrating the effects of light brightness on one's mood and alertness, this piece seeks to very simply mimic a dimmer by leveraging material properties and heating actuation. Embedded with 28 gauge nichrome wire and a bilayer material of PET and aluminum, the piece houses any typical LED light bulb. Due to the difference in expansion rates between the PET and aluminum, when heated, a certain curling occurs, resulting in greater permeability of light. With the nichrome wire's ability to reach up to 50 degrees Celsius within a few seconds, the lamp reacts nearly instantly to its actuation. This piece looks to mediate one's environment through the subtle influence of light diffusion. In order to evaluate these pieces in a timely manner, it was chosen to provoke stress through the 2-minute clinical test, which is often used to determine signs of intellectual impairment, also referred to as the Serial 7 test. While participants focus on their mathematical task, their EDA, heart rate variability, movement, and skin temperature are being recorded through the E4 wristband. From the time of the test begins, these signals communicate if the participant surpasses a certain threshold of EDA and heart rate variability, indicating a rapid onset of cognitive overload, which in turn activates the sensory stimulus embedded in the piece. Please see more about the takeaways of this initial study in the full paper. So what have we learned from all of this? Well, we have seen that the field of effective computing has extensively grown in research around improving software design, but we have yet to see these benefits fully infiltrate into disciplines such as product design, material engineering, and architecture. Our built environment is indisputably essential in being able to integrate these systems seamlessly into the world. And although the projects exhibited in this paper only begin to explore this potential through wearables and furniture augmentations, one can envision a future where these actuated systems and materials become embedded at the infrastructural scale, providing immersive experiences to address societal strain. Beyond the need for greater human-machine communication lies the necessity for technology and design to engage in the pursuit of accessible therapeutics and recognize mental health as a growing crisis which can and should be addressed by our disciplines. Thank you.
Thank you very much. I would like to invite all of our presenters to please turn on your camera and your mic, and we get started with the conversation. Thank you. I kind of want to, these are all fantastic projects. I want to start with some remarks about that basically it's about all of the projects that is presented. All the papers presented in this session are somehow dealing with capturing data, either through the first paper, Olivia and Malgorzata's process of photogrammetry, or Katrina's process of capturing physiological responses from the users, or Zidong's spatial computing of data gathering, or in fact, Anna's use of augmented reality. And without getting too theoretical here, which by the way, I disagree that mere use of photogrammetry could be a way to really understand the philosophy of Baudrillard and the notion of hyperreal. I want to hear from each of you, how do you think about limitations of the tools that you're using in order to understand reality, if we can use that term, either through, let's say, commercial devices like E4 sensor that Katrina used, or camera that Anna used, or any software that, let's say, Zidong used in his projects. What are the limitations of the tools in how these systems help us to see the reality? And allow me to a little elaborate here, because what I mean by that is that, for instance, our perception of the world is very much informed by affordances of our sensory modality. In other words, if we are visually impaired, our perception of the world is going to be absolutely different. So I want to understand how, in the tool that you're using for capturing your data, the perception of that reality that you're constructing are different, and what are the limitations in your specific projects regarding that tool? And I want to open it with that question. Whoever feels ready, just jump in.
I guess I can start. So in the case of my project and the tool that I used, which you mentioned, Manaz, which is the E4, I mean, there's a very obvious limitation, which is that of gathering a full spectrum of information, not only what's happening physiologically, but also environmentally. So I think in my work, I seek to get more and more information, whether that be physiologically and neurologically, to gather a greater understanding of someone's experience of their environment. But this, of course, is, to your point, not taking in full consideration potentially impairments to the sensory system, or even just abnormalities in one's environment. So I think moving forward in the field and in the discipline as well, we're gonna have to look at how one can capture really a better idea and take into consideration also people's personal experiences and limitations. So if one could actually condition that, then I think we could get a better grasp of what tools specifically are needed and how we could augment them for that purpose.
While we're here, Katrina, I am curious from technical point of view to just hear from you. I mean, you're capturing EDA and HRV from your user. This information could certainly show us the arousal level of the users, but how do you differentiate between stress versus excitements? How do you technically differentiate between these two types of information?
Yeah, exactly. Valence, for example, is extremely hard to distinguish. And also, even when you're distinguishing arousal rates or, like you said, stress or excitement, they often get depicted very similarly. So the way in which I was able to kind of almost build in these, quote, conditional statements to understand maybe what is someone experiencing is by looking at, their movement level, the time of the day, whether they're if their temperature is high or low, because then you can start to actually condition. Okay, stress has a high arousal, low variability, but also high temperature, which might not appear when someone is excited. So by building in a multitude of layers, you're kind of setting yourself up for eliminating possibilities of false readings. Saying that, however, it's definitely not a perfect system, and building in more and more information is what's going to help us distinguish specifically what's happening to someone.
That's fascinating. We will come back to this comment. I want to definitely elaborate on this. This is really interesting. I want to open up to others about the question of reality and tools. From the first paper, I really want to hear what you think about the question of where are the limitations of the tools that you used for capturing the reality.
I think for us it was the motivating factor to undertake the study in the first place was the actual what you're saying, Manaz, that we oftentimes take our tools for granted. So we assume, or at least you can see this in the young generation of people that start to enter architecture using digital tools right from the start, that they assume that this is an ultra precise tool. So through our investigation, we attempted to challenge this notion a little bit by taking a closer look at actually the limitations of photogrammetry, which tends to be typically used as a tool for accurately representing reality. But if you start to take a look at the actual data that you input for the tool, this is photographical data. Here you can already see the limitations because depending on the number of photographs, the number of angles from which you take the photographs, this determines the calculations of the software, and this determines the accuracy of the digital model. So actually the human factor, the designer's factor, comes into play already at this stage when you're photographing the real object. If you don't take enough photographs, or if you limit your photography setup in a certain way, then all of a sudden this impacts the digital model that you're dealing with. So in a way, we tried to push this really far by intentionally limiting the photography setup in order to generate the glitches in the model, trying to see what you could do with these glitches. Do they really need to be only a hindrance that you should get rid of? Or could you rather use them as a creative opportunity to start playing around with them from the design standpoint? So I guess that would be a part of the answer. I'm sure that we could talk for maybe an hour or so on this subject, but really briefly, this is from us.
No, I think it's interesting to hear you. I think there is other layers of information that could be very interesting to go with photogrammetry in your future research, I may suggest, especially when you're talking about hyperreality, because I don't think Baudrillard was just merely meant just in terms of the image, or somehow I think the fact that he was even pissed off by metrics was the fact that we can't actually be completely separate from the reality. In other words, and then the reality is not constructed just through the image, but there is the way that it's constructed through even a form of ideology. So how different layers of information could come to this process is really fascinating. And then, yes, medium specificity is really crucial in capturing what is out there in the material world.
Yeah, definitely. I agree that there is a lot of room to maneuver and to explore. This was just a small portion, like a teaser study into what could be done. And of course, this is a much deeper question of the hyperreal.
Anna or Zidane, do you want to add anything, or shall I move to this next question? Feel free if you want to add anything here.
Yeah, I can add something. I think for the particular game concept, it has a lot of limitations, starting from usage of Aruka codes to the application for augmented reality. So there are various of them. But I think the main limitation there is that augmented reality works with visuals only. And but I was developing the idea that you can 3D print your creation after that, afterwards, after playing a game, you can 3D print it and touch it. So the tangibility could be used in perceiving the design solution of a building you obtain during the process of playing. And maybe addition of some audio effects would enhance the experience of design, but still design is pretty visual, I suppose. And I think this is the biggest limitation of my tool.
Yeah, I mean, Anna, your work was really very interesting and offered very interesting insight in how we could bring a sort of relationship between public and architects with capital A, between architects and clients, and really kind of offer interesting insights into sort of design literacy. It was really fascinating to hear your talk. Now, my question is, how do you bring, and I know you talked a little about sort of future iteration of your project, but I want to hear, how do you bring this notion of other layers like race, gender, ethnicity, or socioeconomical issues from the user into your game? Or are you planning to bring those layers in?
Yeah, that's a very good question. Thank you so much. I think, I perceive my game as Sims. The Sims, there are many editions, like Sims Party, Sims, I don't know, Christmas, or so on and so forth. So there could be different layers. And all these layers would depend on AR application only. So you won't need to buy a new game for this, or even the game initially is free. So you won't need to like print out another game. So you will need to pick the mode in the AR application, how to perceive the room cards you are using for like designing a house or something. And like these room cards and the drama cards, if you remember, like I had like some layers which include drama cards and some family cards. And in this part of the game, we can include these different layers, like some problems we can write, like gender problems or any others. So I think it's expandable. It has infinite possibilities to add different layers and different meanings to this game.
And while we are here in the chat, someone asked, is this game available to public? If so, how it could be used in our design studio?
Yeah, this is a very good question too. Unfortunately, right now it's not available for the public. However, I would love to develop the game and make it available as soon as possible. And for the studio purposes, I think I had an experience of teaching freshmen, and for me it was very interesting just to see the way how freshmen learn about architecture and how hard it is for them to jump from nothing to something, like just some initial stages. And I think especially for freshman students, this game would be a very good step forward learning architecture through playing. So it's like because the game is very low threshold, architecture students can develop different modules which you use to combine different houses. So like, for example, my room cards currently, they have just this rectangular part, but it could be shaped in any other way, in like it could be biomorphal, you know, it could be anything they want. And it could be very, very interesting experience for them to see how different modules with different functions can relate and can be juxtaposed one to another.
Thank you, Anna, for your answer. We are looking forward certainly to see this publicly available. The next question, I want to kind of bring Zidong's and Katrina and Jose's projects in contrast to one another and related to the question of empathy and access. Because it's a very interesting question, like the way that we actually can develop a better understanding of access is through developments of empathy. We understand the other, so we can develop systems that it's more accessible. In Zidong's work, we see that because you have to develop a system that accounts for many users, you have to simplify, you have to classify your user. I want to understand how, and in Katrina's and Jose's paper, we see that there is some layer of simplification because you have to reach to some sort of conclusion that what kind of emotion or affective states your user is sensing. We lost Zidong's. I guess I can ask from Katrina's, how do you see the role of technology in developing empathy, still by this reductionist approach in which we are trying to make sense of all this data that we are capturing? How do you think this type of technology develop empathy? And after Katrina, maybe anyone else would like to jump in here. I would love to hear.
Yeah, well, it's a really good point. And I think we already see a lot of the softwares that we interact with today looking at touching on empathy and trying to build empathy amongst people. And I guess, I mean, your work looks at this, and this is what I'm striving for, is how we can translate this empathy into the environments that we live in. So I mean, it's a huge challenge because we sort of live in a pretty static world in terms of the built environment. But I think also kind of touching on an idea in the question about building community empathy, because obviously we can't just look at the individual. It's going to be around definitely making a set of rules that we can understand based on the gathering of data, but also understanding that at times we're going to have to make assumptions based on a collective amount of information, and customize an experience by averaging out maybe the mood of an entire classroom, for example. So those are things I see as potentials for both looking at the individual and the collective when looking at empathy, and then those translating environmentally, not only through the sensorial lens, but also definitely the material lens. So looking at how materials can respond and change, be programmed to empathetically respond. So.
Thank you very much for the thoughtful answer. I know that we are running out of time, but I want to hear if Zidong, because he didn't say anything. I want to make sure you say a few words.
Sorry, there is just some problems about my internet connection, but now I think it is okay. And so I didn't hear your last questions, but I have something to share with the data, because I want to build a participatory design system for community design. So it faces